The next lecture is on a topic called utility function. So we saw last time it was a little bit tricky between which objective to pick, whether should we do maximize the expected value or should we do the option of, if you see here, selecting the most likely or the minimum as a criteria. Which criteria should you select? Now, turns out that, like I said earlier, we won't really get into this business of most likely. That's because it really is applicable only if the probabilities are extraordinarily high. So we will stick with these other two. Now, turns out that there's a nice way of actually merging those two using what's called utility function. And I'm going to give you a brief introduction about this. So, if you think about it, in the previous example, we had those three options A, B, and C that we had. It was not very clear which is a good objective, like I said a little while ago. And we probably won't worry too much about the one in the middle. Now, turns out that, if you think about what you would do, many of us might prefer to play option C as opposed to A, because when the amounts are pretty low, you don't mind taking a bet, okay? However, when the amounts are very high, you're saying, oh, maybe not. Now, if you have seen this TV show called Kaun Banega Crorepati, now it turns out that this is still going on at this point while we are recording. If you've never seen this show, I would recommend pausing this video, going to YouTube and actually watching at least one episode of Kaun Banega Crorepati. There'll be at least 3 or 4 people who would come and do what I'm going to be talking about. I seriously recommend pausing the video and going and watching that, because this example will really ring nicely after that. Otherwise, this would just look like an exercise that is purely academic. Okay, so turns out if you've watched that show and you've come back to see this, or if you watched it before, turns out that in the early rounds, people do take some risks. Okay, when the number of rupees or amount of money that is in stake is small, even if you don't know the answer, you take a guess, okay? Because going back home with a small amount of money is not terribly exciting. So here's the deal. As the numbers become higher, now think of this situation where you're out there, you're the participant, and you have amassed quite a decent amount of wealth, and then you come to a question for which you have no idea what's the answer, okay? Then you would say, the person who's comparing the show is going to say, do you want to do 50-50? And then you would say, oh, okay, we'll do that. And then 2 options go away, you're left with 2. Now, you have a choice of either selecting one or the other by maybe flipping a coin, or you're saying, well, I'll just take whatever money I have and I'll leave. Okay, so you have that option. So now it turns out that when the stakes are a bit low, you might be okay picking that option. But once the rupee amount goes higher, you might say, okay, let me go ahead and pick that. I do want to say that we want to reflect this in what's called a utility function. Larger amounts of money are more useful to us than smaller amounts of money. Therefore, you don't want to risk away larger amounts. So when the amounts are larger, we tend to be a little bit conservative. When the amounts are smaller, we're willing to take risks. So in some sense, in the previous case, now we're saying, oh, we are changing our objective from maximizing, say, being risk neutral, maximizing the expected value, towards maximizing something, or rather, maximizing the worst case situation. Okay, so you're kind of changing that objective. Is there a way to capture that? I do want to say one thing I forgot to do is the show Kaun Banega Crorepati has come in several languages. The one that's in English is called Who Wants to Be a Millionaire. There are versions in other languages. I know for sure there's one in Tamil. If you are not familiar with the Hindi language, you can go ahead and listen to those. It would be the same thing. So Who Wants to Be a Millionaire is what is the show in English. The idea is pretty much the same thing. Okay. Now it turns out that, like I said before, if the amount that is up there is small, you might be willing to gamble and you pick one of the 2 options when you had a 50-50. When the amount is large, you would say, well, I'll just take the money and go. Okay. So typically, you will quit when the stakes are high, and you might risk when it is low. This is what is called utility. So the utility value is not linear, okay, in some sense. So, we want to find a way to see if there is a function that we could use that captures this behavior. So, we would be able to use a single objective to figure out whether which bet is most ideal for us. Okay, that way we'll have just one objective. Again, I do want to repeat one more time that this most likely stuff we're going to put it away, because that's not something that is terribly useful. It's not really an objective that you would use unless the probabilities are really, really high. Okay, so one utility function is what's called the exponential utility function. For the purposes of this course, this is the only utility function that we will talk about. But if you go and read up, there are many other utility functions, and I would recommend that you go ahead and look at that. There are also a lot of people that have criticized the use of utility functions, and again, I am not a proponent of this, but I do want to give you the option of finding a way to get a common metric, if you will. So, there are many such utility functions. Essentially, what you want to do is, as you transition from risk taking or being to risk averse, you want to capture that behavior. You have to capture that behavior where you're going from being risk averse to being I'm saying, by saying risk taking, what I really mean is you are being risk neutral. Okay, so we want to use a function u of x, and we don't worry too much about the function itself, is as x increases, you want to capture your utility. Now, you want to then take this utility function as a single objective which you want to maximize. You want to compute the maxima of that function. Turns out that we could do that exact same thing and pick one objective and optimize among the three options, which is what we will see here. Now, one utility function that is used a lot is what's called the exponential utility, and we write down the exponential utility function like so. U of x is r times 1 minus e to the power minus x divided by r. Now, there are other utility functions as well, but we are picking the exponential just for the sake of picking one and presenting it here. Now, there are many different versions of the utility functions. Some of them use the r in the front like I am, some of them remove that. Some people explicitly take care of positive and negative values. I am not doing that as well. So, we are just picking something fairly simplistic. The idea is to show you how this works, and we will do a little demo towards the end. It will give you a better idea. Now, the reason we call this exponential is because you have this e to the power in the function, and therefore, that is the reason it is called the exponential utility function. And what is this r guy? Now, that is an important thing for we need to talk about, and that is what is going to tell you how you are going to switch from being risk neutral to going to being risk averse. So, this is the r parameter that is fairly important in this analysis, which is what we will see next. So, here we are going to explain this r guy, and in the context of exponential utility functions. So, this r is in the following way. So, let us say we go on increasing the value of r. Okay. Now, you are asking the question for smaller values of r. So, let's do the following. So, let's say you have smaller values of r. Let's say like so I'm going to plot a graph, and I'm writing r here. So, let's say when r is, let's say 200 rupees, and you're saying, well, if it is less than 200 rupees, you're saying, well, okay, I'm willing to risk. Okay. When it's above 200 rupees, I'm saying, well, this is when I would gamble, and if it's above 200 rupees, I would not gamble. Okay, that means the amount is so high, I don't want to lose out 200 rupees. Now, we want to be a little bit more precise here. We are saying the value of r is such that you as a decision maker are going to be indifferent between these two options. The first option is not playing. So, it is essentially this is my r. However, my game is a little bit different. It is not like a gamble or not gamble. I am going to tell you what the game is. The game is the following. There is a 50% chance of getting r rupees, or there is a 50% chance of losing r divided by 2. Okay, so that is the gamble. So, essentially what we are talking about is there is a 50% chance of, so I'm going to say I would pay, so let's say I would pay rupees, so I would pay some amount of money, and I would, let's not even worry about the paying part actually. So I would, there's a 50% chance that I would get, at the end of it I would have negative r over 2, and there's a 50% chance that I will have r rupees. Okay, so that is your eventual outcome. So the negative r over 2 is the amount you pay. So either you pay r over 2 and get 0, or you pay, it's the same thing essentially. So now let's look at this. Now each person will have his or her own r value. Some of us who are very conservative will have a small r value. For us maybe it will be 10 or 20. Some of us who are either not just conservative, if you also have a lot of money, for that person, 2,000 rupees may not be a whole lot of money. Maybe 20,000 is probably reasonable for that person. So each individual has a different value for this r. Each company has a different value of the r. I mean, they talk about company culture. This is what we're talking about. This is one of the things we're talking about. The culture of being risk averse or risk taking. Okay, so let's look at it. Let's pick a specific example of r as 100 rupees. So what does that mean? So that means you would be equally happy not playing the game where you will get 100 rupees or lose 50 rupees with same probability, or play the game. So that's the value. So if you're less than 100, you will surely play the game. If the amount is less than 100 or losing less than losing an amount. So let me just put it this way. R is here. If I was smaller than R, I would gamble. If I am bigger than R, I would not play. So that is the same example we saw here. Okay, so the probability of winning and not winning is 0.5, 0.5, and the amount of money you would win is R or lose R over 2 with equal probability. So that is that value. So let's think about what would be such value of R that you would like to pick for yourself. Okay, it's important to think about that. Now while you do that, so this is what it's saying here, you need to think about what is your own R value. Okay, is it higher or lower than 100? It could be higher, or I would not be surprised if it is lower than 100. So what's an amount of R that you'd feel comfortable enough to gamble? Okay, so this is basically what's the largest number that you'd be willing to consider to gamble away. Either you are losing R over 2 or you're winning R rupees. Okay, so let's move along. So now what we do is we try to maximize the expected exponential utility. That's what we're trying to do for these three gamble options. So what we will do is we will look at the three options. So remember that you pay 100 rupees in the first option, and then with a 30% chance you will get 1000 rupees, and with a 70% chance you will get 0. So that means you will either win 900 rupees net with probability 0.3, or you will lose 100 rupees with probability 0.7. Notice that this is different from the R and the R over 2 we talked about earlier. This is because you want to first select your R right here. Okay, like I said, spend some time thinking about your R before you move to the next slide. Okay, now once you have done that, you're asking, okay, now we look at the three options, and then the second option is as so. You pay 50 rupees, and there's 25% chance that you will get back 500 rupees. So that means your net gain is 450 rupees with probability 0.25, and your net gain is 50 rupees, that is 100 minus 50 with probability 0.5, and you lose 50 rupees with probability 0.25. And the third option is one in which you pay 10 rupees, and then there's a 80% chance you'll get 20 rupees back, and there's a 20% chance you lose that 10 rupees. Okay, now let's take a person whose R is 100. Okay, so that means in the previous case, that means if the amount was less than 100 rupees, you would be betting. If the amount is 100 rupees, you will not enter the bet. Okay, then the utility function for that person is given by this. Okay, so this is a utility function that is important for us. So based on that R, so this is R 1 minus e to the power minus x divided by R. Right? Notice that R is 100. Okay, and the utility function is written as before. So if you notice here, the utility function is R times 1 minus right here e to the power minus x divided by R. Okay, Now let's compute the expected utility, all right. So in the first option, what we do is we compute the expected utility in the following way. Remember, the expected value of a function of a random variable, 0.3 is the probability, times the utility value. So 100 times 1 minus e to the power minus x. So what is x here? In this case it's 900 because it is 1000 is how much you get and you pay 100. So your payoff is 900 rupees. So it is e to the power minus 900 divided by 100. So that is the utility function value with probability 0.3. And your utility is going to be this value with probability 0.7. So if you did your calculation, your expected utility is negative 90.28 rupees. Okay. Now, I'm sorry, it's not rupees, it's units. Okay, so utility function is not really in rupees, although because we multiplied by 100 here, in this case it is still rupees. However, it does, if you don't have the r in there, then it is just another dimensionless quantity. Now, turns out that the second option, we do the same thing. This is the probability times the utility value. So it is 500 minus 50, so that's 450 right here. So we plug in that for x plus 50% probability of this being the utilities. This is 100 minus 50 divided by 100 plus 0.25 multiplied by the utility, which is 100 times 1 minus e to the power 50 or 100. If you look at it, the utility value for that, the expected utility is 28.178. And the third option, option C, tells me that my utility is 0.8, expected utility is 0.8 multiplied by utility for value of x equals 10. Why is it 10? Because it's 20 minus 10, which is 10, or negative 10. So negative of negative 10 is 10, which is 0 minus 10. So okay, that happens with probability 0.2, and I did my calculations, I get 5.5096. I mean, what if it was 1000? What if it was 10? Okay, we asked two questions. What if I have a different utility and not 100? So let's go to the next slide, which is as follows. It says here, now if I plugged in a different set of numbers, one more time, remember these all still remain exactly the same. The first option is to is to gain 900 rupees with probability 0.3 and lose 100 rupees with probability 0.7 and so on. Okay. Now if you look at it, now I have created a little table here. When your utility function is 100, we saw in the previous slide the negative 90.28, 28.18 and 5.51, which we saw here, right, 90 here, 28 here and 5.5 here. That's exactly the same numbers here, except I've rounded off to the second decimal to a paisa. And also, if you look at the 1000 one, notice here that because the utility is as high as 1000, this person is probably happy enough to make this bet, because for this person, winning 1000 rupees or losing 500 rupees is okay, is something that they would be willing to consider as a bet. Okay, so therefore for this person this is a reasonable gamble to make, but also notice how much, just a little bit bigger than the second option. Okay, and that is still because the probabilities are not 0.5 and 0.5. Okay, so you look at this and you'll see that if the R value is really small, your expected utility is really tiny. So depending on your R value, now that is what becomes a big deal in terms of which option you would use. So you would be extremely conservative if your R value is small, and you will pick the third option. If your R value is high, such as 1000, you would pick the option A. If your R value is somewhere in between, say 100, then you would pick option B. So now your best option depends on how conservative you are. A smaller value of R means you're more conservative. A larger value of R means you're a little bit more aggressive than the person who put 10. Now you could say, well, my R could be 10,000 or something like that. Okay, then obviously you are not as conservative. Now it's also a matter of, what does that amount of money mean to you? For someone, 10,000 rupees is a huge amount of money, and they would not be willing to risk that. For some other people who are much better off, much well off financially, for them that might not be the case. Okay, now before I move on to a demo where we will try the 10,000 example, let us quickly make some closing remarks. So the first thing is, the optimal solutions essentially tell you a little bit about how risk averse a person you are. Okay, so the more risk averse person would play the less risky option. Okay, and so the choice of R, basically the smaller the R, the more averse to risk you are. Okay, now as a closing remark, I do want to say this utility function thing, a lot of people have a lot of criticisms. Okay, I am not again a proponent of something like this. It's just to let you know that while this is something that people use, it's used quite a bit in companies, especially if it's not your money. It's a different situation. One of my teachers in school used to tell us when we had our first computer, this is back in the 80s in our school, the teachers would say, think of it as your own computer. And what my teacher essentially was trying to say there was, take good care of it like it is your own. Okay, while we conveniently misunderstood that as think of it as your own, don't bother, play with it as much as you like. Well, in reality, what he was trying to say was, think of that as your own thing, your own money. That's what a lot of companies also do the same thing. When you are at a high position like the CEO, you are pretending like it is your own money when you're gambling. So that means taking risky ventures. All right, so now I'm going to move to the demo. Okay, so what I'm going to do now is do a little demo of what we just saw. So this is again in octave. Actually, all my demos in this course are going to be in octave. So it turns out that what we want is, if we're given these three options A, B, and C, we want to vary the values of R. And you could also change the probabilities. In fact, I'm going to give you this file for you to use. You're welcome to go ahead and play around with these probabilities a little bit, play around with the payoffs. You can play with all those numbers. You can also play around with the costs and see what happens. So now I'm going to pick somebody whose R is 500. Now we'll do the 10,000 a little bit later. So let's say I have somebody whose R value is 500. Now this one is such that now this person is willing to bet anything less than or equal to 500. This person is willing to go into a bet which says I will get 500 rupees or lower with probability 0.5, and I will lose 250 rupees or lower with probability 0.5. So that's this 500, if you remember. All right, so now this is the three numbers, right? For playing the option A, you pay 100 rupees. For playing option B, you give 50 rupees. For playing option C, you give 10 rupees. Now, if you look at the expected utility, I'm essentially writing it in the following way. It is 0.3 times the utility function value, which I'm highlighting here, which is 1 minus e raised to the power negative x. So x is how much money you get. So it is 1000 rupees minus PA, which is 100 rupees, right? That's how much you pay to play the game. Or you would get 0 minus PA with probability 0.7, and I have converted into utility values. So let's see what happens when I use R equals 500. So let me go here. Let me just clear off the previous example right here, and then let me hit clear anyway. I do think there is a clear there in here, right in the beginning, like we do always. Oh, I guess I did not put a clear, so I'm glad I hit the clear. So I'll do util underscore demo. This is utilization underscore demo. So util underscore demo. Okay. So now if you look at the values, it says, well, option A, my utility is 47.714. Option B, my utility is 84.823. Option C, my utility is 5.9004. Okay, so these are my utility values. Okay, so now what happens is, for me, if my R equals 500, my best option is B, the second option, which is 84, which gives me an expected utility of 84.823. So this is the gamble that I would be willing to play. Now, if my utility is way, my R value, sorry, not utility, R value is way higher, so let's say it's 10,000, I'm going to save this file first. Let me just do Control S. Okay, now let us try, let's clear one more time, and then let's do util demo. I presume it would have picked my 500, yes, I mean my 10,000. Now if I use 10,000 as my value of R, then my expected utility is much higher, 187.86. Clearly for somebody whose utility values, I mean R values as high as 10,000, for them to play the first game certainly makes sense. It's the best of the 3 games that they should be playing. Now, if I had a much smaller value, let's say mine is only 5 rupees. Okay, let's see what happens. An extremely small value, I save that, and then I clear and run it one more time. If you cannot see this, I would recommend downloading the program util_demo and then running it. Okay. So you see, notice here all the numbers are negative. Even the last one is negative. That's because even 10 rupees is very, very large for somebody whose R value is 5 and therefore would not be playing any of these options. All the net utility is all negative. Okay. So I just wanted to say that, depending on your value of R, different objectives become bigger. So if your R is 10,000, your best bet, it's 10,000, your best bet is option A. If your R value is 500, your best bet is option B. If your R value is something as small as 5, in fact, you would never even bet here. In fact, if your option is 10, then at least there's a chance for you to, if your R value is 10, there's a chance you would pick option C. However, if your R value is only 5, then even that is not a lucrative option. You should not even be betting in that situation. Okay, so I will stop here. However, I encourage you to play around with these numbers when you get a chance. Thank you.